Alright, so our review for summative number 7 is going to have some new topics on it and a couple of old topics. Well, actually, you know what? I take that back. I think there's just one old topic on it, which would be factoring. And I'm hoping this is the last time we have to talk about factoring on an assessment this semester. This first section, however, is a first attempt at graphing radical functions. So I'm going to ask you to identify any sort of transformations that you see. So the first thing I notice on the square root feature function here is that we have a negative in front, which means we have a reflection over the x-axis. And then there's also a 3 in front as an a value. So there's also a vertical stretch of 3. And then the other transformation I notice is this plus 7 outside of the radical. So that's the vertical shift of up 7. So next what I would expect you to do is get some good points, and you're welcome to go to your calculator's table to get those good points. These are the ones where you have an error if you go in the negative direction. So you have to start, the first time you don't see an error is at the ordered pair 0, 7. So we're going to be plotting 0, 7, and then there should be another nice point at 1, 4. There's another nice point at 4, 1. There's probably another nice point. Let's see. 9. Let's see. 9 square root of 9 is 3. Negative 6 plus 7. I feel like I just did something really goofy there. Hold on. 3. Negative 9 plus 7 is negative 2. So graph as many good points as you can to get a quality graph, and also use your graphing utility for a little help. And then plot accordingly. Now make sure you guys are not plotting backwards. Some of you were having a real tough time with remembering how to plot points and confusing it with slope last time. So, all those transformations that you identified earlier, you should be seeing on your graph here. So this is the starting point of our square root function. This one, oh man, that's ugly. Alright, this one does definitely have, you can see the reflection very clearly. It has been stretched vertically, has been shifted up 7, has not moved right or left any. So, for domain, remember domain is from all your x's from left to right. So the x's begin here at x equals 0 and go to infinity. So just make a little mental note that domain has to be from left to right. And we're going to be real picky about your notation here, because we've been doing domain and range so much in the last few months that we really expect you guys to have a good handle on the order in which the interval appears and the notation that you're using. Notice I used a bracket on 0 because it has an ordered pair there. Infinity is going to use a parenthesis. Now range, remember, make a little mental note to yourself that it is the lowest y value up to the highest y value. So for this one, it is going to move down forever. So as far as the starting of the range, it's going to start at negative infinity, and then the range goes all the way up here to y equals 7, and then it stops. So that's the end of your range. You have to be careful about the order of the interval, and you have to be careful about using brackets versus parentheses. And I am going to mark you down as a concept mistake if you don't get those properly written down. Alright, the next question is for you to try on your own. Please refer to the answer key if you want to know if you did it right. So here's another new concept for you. We're going to be graphing parabolas now in 2 different forms, vertex form and standard form. So we'll start with the easier one, which is vertex form. So remember, the formula for vertex form is a times x minus h quantity squared plus k. So a lot of similarities from another formula we've seen before, several formulas actually. There's a built-in negative here with the horizontal shift, like we always see. And then your vertical shift is off to the side like this, and a is going to help us figure out whether there's a vertical stretch or compression, and then also the sign of the a value tells you whether or not your parabola is opening upwards or downwards. So your vertex is going to be located at h comma k. So what's nice about vertex form is you don't actually have to calculate anything. You should just be able to look at the equation and find everything through inspection. And then after that you can go to your calculator if you want to find more points. So the axis of symmetry is the line that cuts through the vertex. So for these guys, the easiest notation you can come up with is x equals h. Now please, please, please be careful that when I ask you for axis of symmetry, you are giving me a line equation. So x equals whatever that value is. If you just write down like -4, that's not going to be counted correct. Alright, so this first question, the vertex, remember built-in negative here, is located at -4, and then over here is a -5, which means my axis of symmetry is at x equals -4, And we'll show that on the graph in a minute, but please, please, please make a note that you need to put x equals in front of that. If you don't put x equals, I'm going to have to mark you down from a 5. All right, so from here, you do not have to actually do any more thinking. If you want, you can just place the vertex in the middle of your ordered pairs. Oops, that's a -5 though. And then you could go to your calculator's table and figure out the 2 ordered pairs, the one that's above it and one's that's below it. So you should be seeing some symmetry. And I don't want to pull out my graphic calculator right now, but if you enter this into Y1 and you type carefully, you're going to see that when you scroll around on your table to x equals -4, the point that's right above it in the list is going to be, that's -5 over, so I did something very weird in my whatever. Alright, so -5. Let's see, what was I saying? Yep. Alright, so -5, -4. And then, just doing a little mental calculation, if you try for -3, you get -3, also -4. So this is the way for us to double check that we have the right vertex. The points that are surrounding the vertex in your table on your calculator should have what we call symmetry. The y value should be going up just as high for each point. So now we're going to graph. I just noticed my answer key had something goofy, so I got to go fix it. -5, -4, -4, -5, oops, and then -3, -4. Of course, I don't draw very well, but you know, whatever. Here's the other thing I want you to make note of and possibly do the same way I do it. I usually take a highlighter and then I graph the axis of symmetry with my highlighter. So x equals -4. I'm just going to verify. I mean, if I could draw a straight line, I could verify that it went straight through the middle of the vertex, straight through the middle of the parabola. And, yeah, good enough. Alright, so definitely did a good job of graphing that. If I asked you for domain and range, you should be able to come up with those. It's always good to practice, though. Let's come up with this anyways. Domain of every quadratic function is going to be -infinity to infinity, because it stretches forever left and right. And the range on this graph starts as low as -5 and then goes up forever. So bracket -5 to infinity. So the question right next to this one is another quadratic, but this time it's in standard form. So remember, standard form of a quadratic is that ax squared plus bx plus c, where your coefficients, which are a and b and c, are going to be numbers, and they're going to help you calculate the axis of symmetry and then thusly find the vertex. So the axis of symmetry this time, you do have to do a bit of calculation. The formula is -b over 2 times a. And then how do you find the vertex? Well, it's kind of nice. Whatever you just got here, this thing, also happens to be the x value of the vertex. You just had to calculate it as opposed to just looking for it in standard form, in a vertex form. And then how do you find the y value? Is you, I'm going to say plug in, even though we know that's not the official term. We're going to plug in x into the function. Now, I'll be honest, most of you have elected to not do any mental math beyond this little formula. For what a lot of you do is you find your -b over 2a formula, so you find the axis of symmetry first. So x equals, alright, let's do a little calculation here. -b means the opposite of b. So positive 8 over 2 times a, and a is a 2. Remember, if you're doing all your math on your calculator, you don't have to, and I don't want you to, but if you are, make sure you have parentheses in the denominator here. This is really 8 over 4, which means this came out to x equals 2. So that is your axis of symmetry. You would find that first, and then you'd go back and say, okay, well, I know the x value of the vertex is 2. Now, if you don't want to do any more mental math, there's no shame in that, especially on a test when you're stressed out. You would go to your calculator, you plug in the new function, and then you would have x equals 2. So if you program your function into your y equals, and then you go to your table, and you check out where x equals 2, you're going to see whether you have that symmetry surrounding what you think is the vertex. So it turns out, I went ahead and did that. And on my calculator's table, I found out that 2, -5 was the rest of the vertex, and if I look right above it in the list, I got 1, -3, and right below it, I got 3, -3. So I can confirm through the table and through symmetry that we must have done something right for the vertex. If you don't get symmetrical points here, that means you did some wrong calculation on your vertex. So please do check your calculator's table. We're going to graph, of course. So 1, -3, 2, -5, and 3, -3. I don't know why that point is so large. I'm just really hoping I can actually hit the point if I make them extra large, I guess. And then with my axis of symmetry, I like to take my highlighter. I'm proposing that it's at x equals 2, so if I were to draw, oh boy, a line through x equals 2, that should cut straight through the middle of the vertex, through the middle of the parabola. Just for funsies, let's talk about domain. Left to right, this function goes forever, so -infinity to infinity. And then the range begins down here at y equals -5, and then goes up to forever. And it has to be in that order. So the next two questions are just two more examples of you trying those out. And I would like you to try them out and then check the answer key to make sure you're doing all right. I did try to show a lot of work on the answer key, so that way if you get stuck, maybe you'll be able to figure out where you went wrong. All right, these next couple have to be done on the calculator. So the first thing we're going to want to do is get this, whoopsies, typed into y1, get the function programmed. So we're going to go to our calculator, and we're going to type our function into y equals, and then we're going to have to explore with the window, because this is a real-life problem, which means -10 to 10 makes no sense. So, plus 185x, and we're using x instead of t, because that's what our variable is in function mode. Plus 4, excuse me. So, if I go to my window, x, I have a weird window from the previous question, but x is measuring the time that the, whatever it is, the arrow is up in the air. So 4 seconds wouldn't be a really good start time. Let's start at 0 seconds, and I really doubt this arrow is going to be in the air for 90 seconds. So I don't know, I'm just going to go with a 20 and see if that works. For y, it's measuring height. I do like to see a little bit of below ground, if you want to call it that. So I don't like to start at ground level. I like to start below ground. And then this is from an old window, of course. I don't really know about this arrow, but I do see it's going up at a pretty fast velocity. So I'm going to go like 500 feet in the air just to be safe. You know, it's like a go big or go home moment. And I'm kind of guessing. So let's see if this worked out. So let's hit graph. Oh man, see, even 500 wasn't big enough. So I got to go back to the window. I got to extend my range. Let's go like 700 just to be safe. There we go. So I can clearly see where the arrow reaches its maximum, and I can see where it hits the ground as well. So, first question. Oh man, I didn't even have to mess with the window. I just needed to go to the table. Alright. So 2 seconds, 3 seconds, and 4 seconds. Alright, so we're going to copy these numbers over to the table. 310 feet at 2 seconds, 415 feet, and then 488 feet. So sorry, we just explored the window for no reason. Alright. 488. And then it has a follow-up question. It says it wants you to find the average rate of change, which is a fancy way of saying slope, from 2 seconds to 4 seconds. So you're going to take the information from 2 seconds and from 4 seconds, and you're going to find the average rate of change, which would be the change in the height divided by the change in the time. So the height went from 310 feet to 488 feet. So subtract those two, and then the time went from 2 seconds to 4 seconds. So after I calculate this on my calculator, and if you're doing it in one step, that's fine, but you're going to have to use parentheses like this, you're going to get 89 feet per second. So this question, just for another example of it, if you were to type that into your y equals menu and then go to your table, you're going to have new values here. 1 second, 2 seconds, 3 seconds. You get 54.5 feet. This is Mickey throwing a football. And 73.5 feet and 60.5 feet. So again, the y is measuring the height of the ball. They want to know the average rate of change, so that's slope again, from 2 seconds to 3 seconds. So here's 2 seconds, and here's 3 seconds. And remember, you're finding the change in the height over the change in the time. Now watch your signs on this one, because the height of the football is actually decreasing. So when it goes from 73.5 to 60.5, you have to make sure you subtract the time in the same order. So 2 seconds minus 3 seconds. So again, if you're calculating in one step on your calculator, that's great, but get in the habit of using parentheses like this, and this comes out to negative 13 feet per second. So the football is dropping 13 feet per second between those time values. All right, now this question, we do need to get our function typed into y equals, and this time I do need to mess with the window. So we are, what are we doing here? The ball is being thrown, so we're going to have to adjust that window big time from the last question. All right, negative 16 x squared is from gravity, so keep that. And then 38x. I should have just deleted this. This is slow. All right, 38. Let's delete that number, x plus 8. Now, clearly, if I use my old window from that last question, way too big, because we're just throwing a ball here, guys. So, okay, 20 seconds was way too far. The ball is not in the air for that long. So I'm just going to go to 5 seconds. That's usually pretty good for throwing a ball, especially if I'm throwing it. And clearly this person is not like Superman. They're not going to throw the ball 700 feet in the air. So we can probably pull that down to like, I don't know, 50 feet. Kind of guessing, but I'm not real sure. So let's hit graph. That's a pretty good picture. Okay, so you can see the maximum. You can see when it hits the ground. So the first question says, the max height of the ball at what time? So we're going to use our calc menu. Second trace. And we're finding a maximum, so choose number 4. And then you need your cursor to come over to the left side first, because it says left bound. So before it hits the maximum is like, you know, before 1 second. So I'm going to type 0.5. Remember, mine has a really bad lag, so I need to hop over to 0.5 seconds. Now I'm going to go to 1.5 seconds. That'll be to the right. And, ooh, that was a little close. The maximum should be in between those two lines, which it is. Hit enter one more time. And then be careful that you're answering this properly. The x value, remember, was the time. The y value was the height. So when you go to answer here, the max height was the y value of 30.6. Let's round to that for feet. And then what time did it occur? It was at 1.2 seconds. So there's a follow-up question that says, when does the ball hit the ground? So a totally different question here. You're going to have to go back to the calc menu to choose a different command this time, because where it hits the ground is right here. Now, you can probably estimate it's about 2.5 seconds, but we're going to use our calculator to find it for real. So we're going to use this time the 0 command, because the hitting the ground is where the height is 0. And then just got to make sure your cursor's to the left, which we already are. I'm going to hit enter. Oops. Oh, blasted. All right, I got to do that again. Second trace, 0. All right, there we go. Enter. All right, I'm left bound, yes. Now I need to drag it to the right. So past the x-intercept would be at like 3 seconds. So I'm going to go jump to 3. And then the x-intercept is in between those two. So enter one more time. And remember, anytime your calculator gives you this E-12 looking thing, that's scientific notation for like 0.000009. So it's just a bad pixelation issue on your calculator. It's doing really awesome calculus on a crappy picture. So this is really just a 0. So it hits the ground at 2.6 is a fine answer for us, 2.6 seconds. And I do expect you to give me an accurate answer based off of your calculator using the calc features. Alright, so there's a follow-up question there. Check the key after you practice that one on your own. And remember, you can get an emulator on your computer or phone if you have an Android. And final attempt on factoring, guys. So keep your flowchart handy. First thing we do is look for a common factor. There is no common factor between 9 and 16. So it's a 2-term. We're going to use the good twin, evil twin pattern. Remember that guy? So the way the pattern works is you figure out who the square root of each terms are. So 3x and 4. And then one's a plus sign and one's a minus sign. So that's my favorite question. I love those. Now when I look at number 3, I'm back on the flowchart, and it first says to look for a common factor. There is a common factor this time of a 2. So you're going to need to take the 2 out of the problem. And now you have a 25x squared minus 1. But we're not done, because what we just have here is the difference of squares, the good twin, evil twin pattern again. So if you take the square root of each of these, this is where some of you kind of had a problem on the last test. That 2 you took out is still in front of the problem. But now you're going to continue factoring the 25x squared minus 1 into its square roots. So 5x plus 1 and 5x minus 1. Those are the kind of problems where, yeah, you're going to have to do this in 2 steps. So here, let's see, common factor this time, a 5r can be taken out. And when you divide each of these by a 5r, and go ahead and show that if you're having trouble with this part, 5r squared divided by 5r, the 5's would cancel and you just have an r. And then over here, 50 divided by 5 would be a plus 10, the r's would cancel. Now that green thing I just wrote down, that's the final answer. The 5r in front of the r plus 10, that's just taken out a common factor and you can't do any more work because it doesn't fit the next pattern. Alright, this next question, there is a common factor of 3, so you need to start by taking out the common factor of 3 and writing your new trinomial. So x squared plus 11x plus 10. Now that thing I just wrote down in red is going to factor again. This is another 2-step factoring question. So x and x, how about a plus 10 and a plus 1? Let's see if that checks out. Always check your arches here. This is positive 1x, this is a 10x. And if you add them together, you do get your 11x that you need. So yes, again, 2 steps. Some of these are going to require 2 steps. This next one does not have a common factor, so you just have to kind of muscle through the question, starting with what times what gives you 3v squared. Well, that would be a 3v and a 1v. And then at the end of your problem, 4 and 1 or 2 and 2. Are your options. So if I kind of play around with the options, what if I put a 4 here and a 1 here? Because that would give me a positive 12 on the outside arch and a positive 1 on the inside arch. And if I add those together, I get 13v in the middle. So yeah, those are the ones that may take you a couple guesses and checks. So write out your options off to the side, and if you get stuck, just keep writing them out and don't erase them. All right, this next one is similar, where there's no common factor. So you start with what times what will give you 7n squared, and that would be a 7n and a 1n. And then for the last numbers, multiplies to negative 6. So it's going to be 1 positive and 1 negative sign. Could be 3 and 2, could be 6 and 1. So 6 and 1 is not usually my first choice. Sometimes it is though, and I think actually in this case it is going to be my first choice. Because if I put a 6 here and a 1 here, this is a 6 and this is a 7. Now what if I made the 6 negative and the 7 positive? Let's check the arches here. It's a 7n, and then on the inside arch you have a minus 6n. And if you were to add those together, you get a 1n in the middle. So don't discount the numbers that are far away from each other. Doesn't mean they can't happen. Sometimes they do happen. Alright, so lots of factoring practice for you. Good luck, and please make this the last time you have to take factoring, because we're going to move on and more factoring soon.